Assalamu alaikum. Bismillahirrahmanirrahim. At the very first question that we are going to solve is the question 16 of thermochemistry, and this question is about combustion of glucose. First part that is being asked in paragraph A is write the balanced equation for combustion of glucose. You are watching this equation on your screen. You are to write formula of glucose as reactant C6H12O6 solid state. You are to mention physical states, and combustion means reaction with oxygen plus O2. I think that you should write along with this video on your paper so that you can easily understand the question. If you can understand this question, you can solve other questions too by yourself. So first part A is to write balanced equation. I have just told you. You are also watching on your screen. C6H12O6 plus O2 along with physical states, then arrow, and the products are carbon dioxide and water. 6 carbon dioxides and 6 water molecules are 6 moles carbon dioxide or 6 moles water are produced. So please write. Again I am repeating this. C6H12O6 plus O2 arrow gives C6H12O6. Plus gives CO2 plus H2O, and when you balance, you will get 6 moles CO2 and 6 moles H2O. That is the answer to the first part of question 16. Second part is to determine the molar heat of combustion. In the question is given heat of combustion for 1 gram of glucose. So first of all, you are to calculate the molar mass of glucose. You know that mass of carbon is 12, or molar mass of carbon is 12 grams. That of H is 1, but here H are 6, you are to multiply 1 with 6, and here H are 12, so you are to multiply hydrogen mass 1 with 12. Then O6, the mass of oxygen is 16, then you are to multiply 16 with 6. As a result, you will get molar mass of glucose 180 grams 180 grams per mole. Now comes to B part of question 16. 1 gram of glucose equal to that, it means that it gives heat 15.865 kilojoules, and you are to determine molar heat, and 1 mole of glucose is 180 grams. So in the second step, you will write in under section B, 180 gram of glucose will give heat, so you are to multiply equal to 180 into 15.65. So you have to multiply the heat that is produced by 1 gram, which is 15.65 kilojoules, to 1 mole mass of glucose. That yields how much heat to that energy, to that heat. That is 180 to 15.65, and the result would be 2817 kilojoules per mole. Since heat is released, combustion is always exothermic, so you are to put negative sign along with 2817 with negative sign, that is exothermic reaction, and you are to put the value of 2817 along with negative sign. Part C is you are to determine the heats of formation of glucose. For such question, you are first of all to write target equation. Heat of formation is the heat released under standard conditions when 1 mole of the compound is formed from its elements. In this question, elements a compound under concentration is glucose, and glucose is formed from carbon, hydrogen, and oxygen. So first of all, you are right the target equation. So you write 6C plus 6H2 plus 3O2 arrow C6H12O6 indeed in solid state, and again next delta H naught F with question mark after semicolon. That is you are to find the enthalpy of formation. So you are to reach this equation with the help of given data. Now what is the given data? Next step is combustion of carbon. Write equation for this. C solid state, O2 gas, C plus O2 arrow carbon dioxide, and then you are to put its rate of combustion value, that is minus 393.5. The second step of this one, data one, is combustion of hydrogen. Next you are to write combustion equation for hydrogen. So write down please. H2 plus half O2, 1 by 2 O2, yeah, 0.5 O2 arrow H2O, and put values of enthalpy of combustion, that is 285.85. Both enthalpy of combustions of carbon and hydrogen are negative since it is evolved, energy is released. Now the third equation also given is combustion of glucose, which you have previously written. So write that equation again. C6H12O6 plus O2 arrow gives carbon dioxide and water. Balance it. 6 carbon dioxide, 6 water, and the heat released is minus 2817, which you have calculated in step B. 2817 kilojoules per mole. After that, multiply the equation of combustion of carbon with 6 and of combustion of hydrogen also with 6, so that we get 6 moles of carbon dioxide in combustion equation of carbon and 6 moles of water in combustion equation of hydrogen. This is necessary because you are to cancel out, because in your target equation no carbon dioxide, no water is present. So now after multiplying both these equations with 6, you are to add these two equations. First, when you multiply carbon combustion equation with 6, you get 6 carbon, 6 O2, 6 carbon dioxide. You are also to multiply 393.5 with 6, then you may perhaps get 2361 minus sign. Similarly, 6 when you multiply the hydrogen combustion equation with this number, that is 6, you get 6H2, and 6 into 1 by 2 O2, you will get 3 O2, and you also get 6H2O. You are to multiply 285.85 also with 6, you may get 1714.8 with negative signs. Now you are to add these equations, and you are to also add their heat values also. So when after doing this, then glucose is on the left hand side in the combustion reaction of glucose. You are to either invert this equation. When you change this equation, that is products will be put in the reactant side and reactants in the product side, their enthalpy value will also change. Instead of negative, now you will have 2817. Other way is to, after adding combustion equation of carbon and hydrogen, you may subtract glucose equation from this. The thing that you are to bring on the opposite side is to be subtracted. One of the two ways you may adopt, and if you want to subtract one, then place negative sign with glucose, negative signs with 6O2, negative signs with 6 carbon dioxide, negative sign with water. Otherwise you may place 6H2O 6O2 on reactant sides and glucose plus 6O2 on the product side. And you are to change energy values also. Now after subtraction, or if you going to invert to reaction, then you may say that after addition, the things that are on the product sides and same are present on the reactant side, they may be cancelled out. You will find on the screen that carbon dioxide 6, they are cancelled out. H2O 6, they are cancelled out. All other things will be cancelled out. Oxygen will be after subtraction. You will get 3 O2 there. So when you manipulate these equations, add combustion and hydrogen combustion and carbon combustion equations and subtract glucose equation along with their energy values, you get your target final equation, that is 6 carbon, 3 O2, 6O2, 6H2 and glucose plus enthalpy of formation value may be whatsoever the result of calculation is 1258.8 kilojoules per mole. This question has been perfectly solved here, and you can watch here on screen. You are to first of all read the numerical, then you are to calculate what is demanded first of all, to write balance equation for combustion of glucose. Same equation is later on used as a data as well when you solve the part C of the question. So I am going to repeat again. Balance equation you have written, you can watch, you should write, you should practice. And then second step is to calculate 1 gram energy is generated or yielded when glucose burn is amount given 15.65. So 180 will give, when you multiply 15.65 with 180, you will be able to get energy released by the combustion of 1 mole of glucose. That is part B, to determine the molar heat of combustion. And part C is first of all, from the given data, write balanced equations. Carbon plus O2 combustion equation, hydrogen plus O2 combustion of hydrogen. These are also formations equation also. 393.5 kilojoules for combustion of carbon, 285.85 kilojoules for combustion of hydrogen. Then again write the combustion of glucose, C6H12O6 plus O2, 6 CO2, 6H2O, and put 6 with O2 and put the value which you have calculated earlier, 2817 in front of the equation. After doing that, you are to reach up to target equation, that is 6 carbon 6H2 plus 3O2. For to get that equation, you know that there is no carbon dioxide, no water. Multiply combustion of carbon equation with 6 along with their heat values. Multiply combustion of hydrogen on with their heat values. Add both these equations and then subtract glucose combustion equation from this one along their values, and you will be able to find final equation in required form. So these questions, the questions are done in this way. Thermochemistry chemical. In thermochemical equations, it is necessary to put physical state. So while writing numericals, you should also put physical state as a subscript in the balanced chemical equation. I hope this video will be helpful to you, and if you properly do at least one question, you will be able to do other question too. Thank you so much. Allah Hafiz. Pakistan.